Welcome to your AI college. Today we will discuss about the RAG. RAG is stand for Retrieval-Augmented Generation. Now, before we go in deep and understand the definition of RAG, let's first understand what problem we had and how RAG is solving that problem. Assume you have joined a new organization and you're wondering how can you raise a new request to get a repository access, or maybe the different dashboard like Grafana dashboard, New Relic dashboard, etc. Or another example, let's say you want to know what is the leave policy of this organization, right? And you want to apply for a leave and you don't know, right? And as you have the cloud access or LLM access within your organization, you might think that I can ask this question to LLM, and LLM or either cloud can help me. But can LLM answer this question? So the answer is no. Why? Because LLM are trained on the public data. They don't know about your internal way of doing something, right? They don't know like how you can raise a request to get a repository access within your organization. They literally don't know. So even if they answered, it could be wrong, generic, or hallucinated answer. Now that is the problem which need a solution. Another example of the teammates has introduced a new microservice and you want to integrate with it, right? So to integrate it with, you want to understand its API contract, its HLD, etc., right? And maybe you have a LLM access and you want to try with LLM and ask this specific information. Does your LLM have this information? Obviously no. Like these are the recently created and private data, so obviously LLM won't know about this information, and even if it is answer, it can be generic, wrong, and hallucinated. So this is the problem which need a solution. Now you might think, why can't we just give the whole company document to LLM along with the user prompt, and with this we can generate the response from LLM. This is purely doable, but it comes with some drawbacks. Drawbacks are like token limit, cost, quality, and latency. Token limit. So every LLM has their own set of limit, like kind of finite context limit. And if you're going to breach it, then the answer is no answer may be like wrong, right? Or maybe hallucinated answer. Second is a cost. Now, if you give a big document, though you might not breach the limit, right? But every token is count and every token cost you money. So the bigger the prompt, the you will get a more cost. Latency. So bigger the prompt, slower the responses. Quality. Overstuffed prompt produce the worse results. Now what is the solution? An answer is RAG. RAG stand for Retrieval Augmented and Generation. Retrieval means like getting the relevant context or data from the whole big document. Augmented is the retrieved data will be attached to the user prompt. And generation is giving this user prompt plus retrieval data to the LLM and get the response. Now let's just discuss how RAG actually work. So assume you have this black box, okay? This black box accept some kind of a sentence and give some relevant set of chunks. Example, you ask or maybe you request this like, how can I raise a git request? How can I raise a git access request? Okay, and this black box return a list of chunks text related to this user query, and relevant chunks could be like git access approval workflow, okay, information required for a git access. Okay, so all this relevant chunks it will return. Now, so assume this is just a black box. We'll go more in a deep into the in upcoming slides. Okay, now let's just see, okay, let's say your user came, okay, and it requested how can I raise a git access request. Okay, then orchestrator send this the same prompt to this black box, and black box give this all the relevant chunks. Okay, now this orchestrator append or augment this list of chunk to user query, okay, and then send to the LLM. Okay, now LLM has the user prompt plus it has all the relevant list of chunks. Now it can generate the result or the response properly and give the generated response. And now the same generated response will transfer it to user. Now here, if you see, we are retrieving the information. Okay, we are retrieving the information from this black box. So this is the retrieval. We are appending the list of chunks, right, to user query. This is what is augmented. And now we are asking LLM to generate some response. That is the generation. So this is what the RAG is, and this is how it works. Now, before we understand what is inside the black box, we need to get ourselves familiar with a few terms. Terms like semantic search, embedding, embedding model, vector DB, and chunking. Now, what is an embedding? So, embedding is nothing but a vector representation of your data. Assume, or maybe just let's take an example. I love dogs. This is a sentence which you are giving, and if we convert into this embedding, vector embedding, you can say, it will come. And possibly it will come like this: 0.21 minus 0.45, 0.67, and 0.10. These are just a pure example. It could be different, right? Whatever the embedding model generate, that would be the correct. But here I am just giving an example. So let assume this I love dogs give this vector, embedding vector. Now let's say I say I like puppies, so it will have this embedding vector. And let's say I say I drive a car, and it will have this embedding vector. Now if you see closely the vector of those first two sentence, right, and if you try to find the difference, right, it comes very less, right? Let's say 21 minus 19, it's just a 2. 45 minus 43, just 2, right? So now if you now if we plot all this point into the 4 dimension matrix, right, and so those two sentence will be plotted very close to each other, right? Whereas the third sentence, I say I drive a car, and now if you compare its values, right, and if you try to find its difference, the difference is more compared to the I love dogs and I like puppies, right? Now if you plot this into the 4D dimension, it will be a far from this other two sentence, and that's what we need, and that's what vector db going to store. Okay, so there is an embedding model to which we will going to give our sentence. Embedding model will give us this vector, and that vector will going to store into the vector db. Now let's just take another example. Let's say you have a list of documents, right, and those documents contain, right, paragraphs like, how to train your dog, best food for puppies, how to repair a car engine, dog grooming tips, car maintenance guide. You have all sort of this document, and now user query is, how do I take care of puppy, right? And now if you give this sentence to vector db, and if you do this vector search, kind of a similarity search, then vector db can give you this best food for puppies. So like the matching score is like 0.92, right? How to train your dog, so matching score is 0.88. Dog grooming tips, score is 0.75. So if you see, the top k results are written to the llm. So whatever the user query is, the vector db try to find the similarity from your available documents, and that give the top k result. Okay, and this top k result we will give to the llm along with the user query. So this user query plus all this context or this chunks which written by the vector db will give to the llm, and now llm will have more context about your internal documents, right, and your internal process and all, and now your llm can answer this better way. Now let's just understand the other key component of a black box: embedding model, vector database, and chunking. Chunking is nothing but a kind of a process which will split your big document into the small chunk. That chunk will send it to the embedding model, and that embedding model will give us a embedded vector. And that embedded vector will going to store into the vector database. Now as we have learned about different terminology like vector DB, chunking, embedding LLM, Now let's just see how all this come together and help us in achieving the processing of private document. So either user or admin can give this private document to the orchestrator server. That orchestrator server will invoke the text splitter algorithm. Okay, and the text splitter algorithm will return the list of chunks. A chunks is nothing but a small kind of paragraph, you can assume. It will return all this a list of paragraph or list of chunks. Now this orchestrator server call the embedding LLM. Embedding LLM will give the embedded vector for each of the chunk. Okay, and orchestrator server will store that vector into the vector DB. And this is how the pre-processing will work of your private document. Now your vector DB stored your private document in an embedded way. Now if anyone try to query your vector DB with some relevant query, it will return the proper response. Now as we have seen how to pre-process the private document and store its chunk into the vector DB. We have stored all the embedded vector, and that embedded vector we got from the embedding LLM. Now let's just see how end-to-end RAG actually work. So let's say here user is asking how can I apply for the leave. Okay, it reached to the orchestrator server. Now we can't just give this whole user prompt to the vector DB. Vector DB can just take the embedded vector only, and then only it can return the relevant chunks. So for that again we have to hit the embedding LLM with the user prompt, and the embedding LLM will give the embedded vector. Now that embedded vector will send to the vector DB, and then vector DB will give all the relevant chunks, list of chunks it will return to the orchestrator server. Now orchestrator server has both the user query and the relevant document which are coming from the vector DB, and the whole context will send to the LLM. Now LLM has the more context, or the context which are coming from your private document, okay, which LLM was not trained on. Now LLM can answer it, can generate the answer in a better way. Okay, and once it generates the answer, it gives to the orchestrator server, and from the orchestrator server it goes to the user. I hope you have understood now what is a RAG is and how it actually work. Okay, if you like this video, please hit a like and subscribe our channel, Your AI College.